Imagine seeing a wind turbine that produces electricity without a single spinning blade. At first glance, it looks more like a sculpture than an energy machine. Yet, this unusual structure could challenge one of the world's most recognizable renewable technologies. For decades, wind power has depended on giant, rotating blades. Those blades transformed landscapes and helped accelerate the clean energy transition. But they also introduced challenges that engineers never stopped trying to solve. Noise, maintenance costs, transportation difficulties, and wildlife concerns remain part of the conversation. Then, a radically different idea emerged from an unexpected source. The breakthrough came from a phenomenon engineers once considered a problem. That phenomenon is known as vortex-induced vibration. Under the right conditions, wind can make objects oscillate with surprising force. Instead of fighting those vibrations, some engineers decided to harvest them. That decision opened the door to an entirely different vision of wind power. A wind turbine without blades sounds impossible, but the physics behind it are surprisingly real. And the story begins long before the first prototype was built. Engineers have studied wind-induced vibrations for generations. Bridges, chimneys, towers, and cables all revealed the power of oscillating airflow. Sometimes those vibrations became dangerous. In extreme cases, they contributed to structural failures. Researchers learned that wind naturally sheds alternating vortices behind objects. Those vortices create repeating forces that push structures back and forth. Most engineers wanted to eliminate the effect. A few wondered whether the motion itself could become a source of energy. That question eventually inspired modern bladeless turbine projects. Their goal was not simply to remove blades. Their goal was to rethink how wind energy could be captured. The result looked deceptively simple. A tall mast anchored to the ground. No gearbox. No giant rotor. Just controlled vibration transformed into useful electricity. To understand the technology, we need to follow the wind itself. As air moves around the tower, vortices form behind it. These vortices alternate from one side to the other. That alternating pattern creates rhythmic forces. The tower begins to sway. The movement is carefully controlled rather than chaotic. Engineers tune the structure to resonate efficiently with wind conditions. Resonance allows small forces to create larger motion. That motion is then converted into electrical energy. Some designs use electromagnetic systems. Others explore alternative conversion mechanisms. The absence of rotating blades changes the entire architecture. Fewer moving parts can potentially reduce maintenance demands. The design can also be lighter and easier to transport. Yet, the greatest challenge remains efficiency. Capturing energy from vibration is harder than it sounds. Supporters believe bladeless turbines could open new possibilities for renewable energy. Their visual footprint is dramatically different from conventional turbines. They may operate more quietly in certain environments. They could be easier to install in difficult locations. Some advocates suggest lower maintenance costs over time. Others highlight the absence of sweeping blades. However, every engineering solution introduces trade-offs. Traditional turbines remain extremely effective at large-scale power generation. They benefit from decades of optimization and industrial experience. Bladeless systems still need to prove themselves commercially. Researchers continue measuring durability, output, and economic viability. Real-world weather conditions are unforgiving test environments. Wind speed varies.
Turbulence varies.
Energy demand varies. Any successful technology must survive all three realities. The global demand for clean energy continues to rise. Nations are searching for every practical source of low-carbon electricity. Innovation often comes from challenging assumptions. The assumption here was simple. Wind turbines need blades. Bladeless engineers questioned that belief. Whether they succeed or fail, the experiment itself is valuable. It expands the range of ideas available to future energy systems. Some innovations transform entire industries. Others influence progress in smaller but important ways. Bladeless wind technology may ultimately become one of those stories. A quiet idea born from a vibration once considered a nuisance. A reminder that nature often hides solutions inside its problems. The next time you see a wind turbine, look beyond the blades, because the future of wind power may not spin at all. And somewhere in the invisible movement of the wind, another revolution may already be waiting.